So in this question, we have to find out the number of values of x satisfying this given equation right here. Alright, so in the question, this is the equation given to us, and here we have assumed the base to be a, and a is equal to x square plus 7x plus 11, and we have assumed the exponent to be b, and b is equal to x square minus 4x minus 21. Alright, and what has been given to us in the question? It's been given that a raised to power b is equal to 1, and we have to find out the values of x such that a raised to power b is equal to 1. Alright, so in what cases do we get a raised to power b equal to 1? The case 1 is when the base is equal to 1. So when we have the base to be 1 raised to power anything is equal to 1, and that's why that becomes our case 1. Now case 2 is when the base is not equal to 0 and the power is equal to 0. So when the base is not equal to 0 and the power is equal to 0, we know that it will be equal to 1 because anything raised to power 0 except 0 is equal to 1. So that's case 2. Now case 3 is when your base is equal to negative 1 and your power or your exponent is an even number. Now we know that negative 1 raised to power 2 is 1, negative 1 raised to power 4 is also 1. Basically, negative 1 raised to power any even number is equal to 1. So these are the three cases for which a raised to power b is equal to 1. So let's talk about the case 1 here where a is equal to 1 or the base is equal to 1. So when base is equal to 1, what we have got is x square plus 7x plus 11 equal to 1. Now here if we take 1 from right hand side to left hand side, what we will get is x square plus 7x plus 10 is equal to 0. So we have got a quadratic equation here, and we can factorize this quadratic equation by splitting the middle term. So when I split the middle term here, what I'll get is x square plus 2x plus 5x plus 10 is equal to 0. Alright, now if I further solve this and further factorize this, what I will get is x plus 2 multiplied by x plus 5 is equal to 0. So we have got our two linear factors, x plus 2 and x plus 5. Now their product is equal to 0. That means either of them can be 0. So either x plus 2 can be 0 or x plus 5 can be 0. Alright. So when x plus 2 is equal to 0, x is equal to negative 2, and when x plus 5 is equal to 0, x is in negative 5. So we have got two values of x, which is negative 2 and negative 5, for which a raised to power b is equal to 1. Alright, so that's case 1. Now let's talk about case 2. Now in case 2, we have to take the power, the exponent to be 0, given that value of a, the base is non-zero, that is x square plus 7x plus 11 is not equal to 0. Alright, so what we have got here is by putting base is equal to, by putting power or the exponent to be equal to 0 is what we have got is x square minus 4x minus 21 is equal to 0. Alright, now again I can factorize this quadratic equation by splitting the middle term. Now when we split the middle term, what we'll get is x square minus 7x plus 3x minus 21 is equal to 0. Now if I further solve this equation, what I will get is x minus 7 multiplied by x plus 3 is equal to 0. Now the product of these two factors is equal to 0. And either of them can be 0. So if x minus 7 is 0, we have got x is equals to 7. And when x plus 3 is equal to 0, we have got x is equal to negative 3. Now an important thing to note here is for these two values of x is equal to negative 3 and x is equals to 7, the base, which is x square plus 7x plus 11, will be non-zero. As it will be non-zero, it is safe to take these values. So we will take the value of x to be negative 3 and 7 from case 2. All right, now moving ahead to case 3, where the base is equal to -1 and the power should be even. Now what we'll do is we'll first put the base to be equal to -1, and this is what we will get. Now here if I take -1 from right hand side to left hand side, what I'll get is x squared plus 7x plus 12 is equal to 0. Now again I can factorize this quadratic equation by splitting the middle term, and once I split the middle term, what I'll get is x squared plus 3x plus 4x plus 12 is equal to 0. Now if I further solve this left hand side of the equation, what I'll get is x plus 3 multiplied by x plus 4 is equal to 0, or x is equal to -3, or x is equals to -4. So we have got two values of x, -3 and -4. But one thing we have to note here, we have calculated the values of x for a equal to -1. But we still have to find out for these values of x whether b is even or not. And b is defined as x squared minus 4x minus 21. Now here if I substitute the value of x as -3, what I will get is -3 whole square minus 4 multiplied by -3 minus 21. On further solving this, what I'll get is 9 plus 12 minus 21, which will result in 0. And we know that 0 is an even number. That means x is equal to -3 is an acceptable value of x. Alright, now let's talk about the second value of x, which is x is equal to -4. Now if I substitute x is equal to -4 in b, what I'll get is -4 raised to power 2 minus 4 multiplied by -4 minus 21. b is equals to 16 plus 16 minus 21, which is equal to 11, and it is odd, right? Hence it is rejected. So the value of x that we have got from here is x is equals to -4, but we have to reject it because the answer of b that we are getting here is odd, which is 11. All right, so the values of x satisfying the equation, we have -5, -3, -2 and 7. Right, if you remember from case 2 also we got the value of x to be -3. So basically the number of solutions that we are going to get for this quadratic would be -5, -3, -2 and 7, and that would be 4. The number of solutions would be 4, which is our option B. So in this question, we have been given a quadratic equation, which is k minus 2 x squared minus k minus 4 into x minus 2 equal to 0. And it's been said that k is not equal to 2. And we know that k should not be equal to 2 because the leading coefficient, the coefficient of x squared, should not be equal to 0. Now, it's been also given that the difference of the roots is 3, then the sum of the values of k. We have to find out the sum of the values of k. So this is the equation given to us in the question. Let me assume that it has two roots, alpha and beta. If alpha and beta are the two roots of this quadratic equation, then alpha plus beta would be minus b by a, and alpha beta is equal to c by a. Now, what are the values of a, b and c? What are we going to do? We are going to follow the same drill of comparing the given quadratic equation with the standard quadratic equation ax squared plus bx plus c equal to 0. And once we do that, we will get the value of a to be k minus 2, b is equal to negative of k minus 4, and c is equal to -2. So we have got the value of a, b and c. Now if we substitute those values of a, b, c in these two equations right here, what we will get is alpha plus beta, that is sum of the roots, is equal to k minus 4 divided by k minus 2, and the product of the roots, which is alpha beta, is equal to -2 divided by k minus 2. But that's not all, right? We have been given one more information in the question, and that is the difference of the roots. So the difference of the roots in the question, it's been given as 3. All we have to do is now use these three pieces of information to find out the sum of all the values of k. Alright, so what we will do here is we can square on both sides. So when I square on both sides, I get alpha minus beta whole square is equal to 9. Now alpha minus beta whole square can be written as alpha plus beta whole square minus 4 alpha beta is equal to 9. Now when we put alpha plus beta as k minus 4 divided by k minus 2 and alpha beta as negative 2 divided by k minus 2, what we will get is k minus 4 divided by k minus 2 the whole square minus 4 multiplied by negative 2 divided by k minus 2, and this is equal to 9. Which on further simplification gives us this equation right here, which is 9 is equal to k minus 4 divided by k minus 2 the whole square plus 8 divided by k minus 2. Right? Now if we take LCM right here, what we will get is 9 is equal to k minus 4 the whole square plus 8 multiplied by k minus 2 whole divided by k minus 2 the whole square. Now we know that k is not equal to 2 as given in the question, so it's safe to cross multiply k minus 2 the whole square on the other side. So what we will get is 9 multiplied by k square plus 4 minus 4k is equal to k square plus 16 minus 8k plus 8k minus 16. Now these two terms cancel each other and these two terms cancel each other. So what we will get here is 8k square plus 36 minus 36k is equal to 0, which can be further written as 2k square minus 9k plus 9 is equal to 0. So we have got the quadratic equation in k, which is 2k square minus 9k plus 9 is equal to 0. Now we can actually factorize this quadratic equation by splitting the middle term minus 9k as minus 3k and minus 6k. So when we do that, what we will get here is 2k square minus 6k minus 3k plus 9 is equal to 0. From here what we got is 2k minus 3 multiplied by k minus 3 is equal to 0. So we have got two values of k. K is either equal to 3 or k is equal to 3 by 2. Now we have got the values of k as 3 and 3 by 2. We can say that the sum of the values of k is 9 by 2, because 3 plus 3 by 2 is equal to 9 by 2. And that is our final answer, which is option B. The sum of all the possible values of k is equal to 9 by 2. So in this question, we have f of x defined as a1x square plus b1x plus c1 and g of x defined as a2x square plus b2x plus c2, where both a1 and a2 are non-zero distinct real numbers. We also have p of x defined as f of x minus g of x, where p of x is equal to 0 only at x equal to minus 1 and p of minus 2 is equal to 2. Then what is the value of p of 2? All right. So a lot of information is given to us in this question. We are going to take one information at a time and find out the answer of this question. All right. So we have been given that f of x is a1x square plus b1x plus c1 and g of x is a2x square plus b2x plus c2, where both a1 and a2 are non-zero distinct real numbers. All right. We also have p of x defined as f of x minus g of x. So we'll get p of x is equal to a1x square plus b1x plus c1 minus a2x square plus b2x plus c2. If I simplify it further, what I'll get is x square multiplied by a1 minus a2 plus x multiplied by b1 minus b2 plus c1 minus c2. All right. Now I can write p of x as ax square plus bx plus c, where a is equal to a1 minus a2, b is equal to b1 minus b2 and c is equal to c1 minus c2. All right. Now p of x is equal to ax square plus bx plus c. It's also given in the question that P of x is equal to 0 only at x is equal to -1. That means we are going to get a perfect square at x equal to -1. So it would be a perfect square of x plus 1. So we can say that P of x is equal to a multiplied by x plus 1 the whole square. Alright, so we have P of x defined as a multiplied by x plus 1 the whole square. In the question it has been given that P of -2 is equal to 2. Then we have to find out the value of P of 2. Alright, I'm going to use this information P of -2 equal to 2 to find out the value of a. So what we'll get is P of -2 is equal to 2. And what is P of -2? It will be a multiplied by -2 plus 1 the whole square, and it is equal to 2. If I simplify it further, I get a is equal to 2. Now if I put a is equal to 2 back in the definition of P of x, what I'll get is P of x is equal to 2 multiplied by x plus 1 the whole square. Now we have to calculate P of 2. So P of 2 is equal to 2 multiplied by 2 plus 1 the whole square, which is equal to 2 multiplied by 3 square, which is 2 times of 9, which is 18. Hence we can say that the value of P of 2 is 18, which is option C. Right, so in this question, we have been given this quadratic equation and we have to find out the set of values of a for which the sum of the roots and the product of the roots of this quadratic equation would be less than 1. Alright, so this is the quadratic equation given to us in the question. Now if we assume that alpha and beta are the roots of this quadratic equation, then the inequalities that we will get is alpha plus beta is less than 1 and alpha beta is less than 1. Alright, because in the question it was given that sum of the roots is less than 1 and product of the roots is also less than 1. Now from here we can calculate alpha plus beta. We know that alpha plus beta is equal to minus b by a, where a is equal to 1, b is this and c is this. Now here if I substitute the value of b as minus of a square minus 5a plus 5, so and value of a as 1, then the sum of roots that I will get is a square minus 5a plus 5, and the product of the roots alpha beta, what I'll get is 2a square minus 3a minus 4. Alright, so we have got sum of roots and we have got product of the roots, and using these two values we have got our inequality. So we have got two inequalities, a square minus 5a plus 5 less than 1 and 2a square minus 3a minus 4 is less than 1. Our cue here is and means later when we solve these two inequalities we have to take the intersection of both the values of both the sets of a's. Alright, so let's solve the first inequality here. Now if I carry this one from right hand side to left hand side, I'll get a square minus 5a plus 4 less than 0. Now I can easily factorize this quadratic equation using the split the middle term method, and the factors that we will get is a minus 4 multiplied by a minus 1 is less than 0. So basically a will belong to the interval 1, 4. Why? Because we can use the wavy curve method to solve this, and when you solve this you will get the value of a belonging to the interval 1, 4. Alright, now let's solve the second inequality here. Now here if we bring this positive 1 to the other side, what we will get is 2a square minus 3a minus 5 to be less than 0. Now again if I factorize this quadratic equation using the split the middle term method, what I will get is 2a minus 5 multiplied by a plus 1 is less than 0. Now again using the wavy curve method, when we solve this inequality what we will get is that a belong to the interval minus 1, 5 by 2. Alright, so we have got the values of a. We have got the set 1 where a belong to the interval 1, 4. We have got the set 2 where a belong to the interval minus 1, 5 by 2. Now here our Q was and what do we have to take is intersection. So when we take the intersection, so let me plot this for you. 1, 4, 5 by 2 and negative 1. All right, so we have got one interval from 1 to 4, open at 1, open at 4. All right, we have got another interval from negative 1 to 5 by 2, open interval and open interval. Now if you take the intersection of them, we have got this region right here, which is 1 comma 5 by 2. So basically the intersection of these two set of A will give us our final answer, and that is A belong to the interval 1 comma 5 by 2, and that is our final answer, which is option D. So in this question, we have to find out the number of non-zero solutions of the equation x square minus 5x minus 6 times signum of x equal to 0. All right. So in the question, this is the equation given to us. X square minus 5x minus 6 signum of x is equal to 0. Now we know that signum of x takes 3 different values depending upon the value of x. That is, when x is less than 0, signum of x is equal to negative 1. When x is equal to 0, signum of x is equal to 0. And when x is greater than 0, signum of x is equal to 1. Now, depending upon these 3 different values of signum of x, we will also get 3 different quadratics. Right? So when x is less than 0 and signum of x is equal to negative 1, the quadratic that we will get is x square minus 5x plus 6. Now when x is equal to 0 and signum of x is equal to 0, the quadratic that we will get is x square minus 5x. Now when x is greater than 0 and signum of x is equal to 1, the quadratic that we will get is x square minus 5x minus 6. So basically for 3 different values of signum of x, we will get 3 different quadratics. Alright, so let's talk about them one by one. Alright, so here we have x less than 0 as the case 1. Now when x is less than 0, the quadratic that we will be considering is x square minus 5x plus 6. Basically the equation that we will get is x square minus 5x plus 6 is equal to 0. Now what we will do is we will factorize this quadratic equation by splitting the middle term. Alright. So when we split the middle term, what we will get is x square minus 2x minus 3x plus 6 is equal to 0. Now if I further solve this, what I will get is x minus 2 multiplied by x minus 3 is equal to 0. Now the product of 2 terms is equal to 0 when either of them is 0. So when x minus 2 is equal to 0, x is equal to 2. And when x minus 3 is equal to 0, x is equal to 3. So we have got 2 values of x. X is equal to 2 and x is equal to 3. Alright. Now one thing we have to take care of. What is that? We have taken case 1, and case 1 suggested or had the condition that x should be less than 0. Alright. So now when x is less than 0, we got this quadratic equation, and the roots of this quadratic equation are x is equal to 2 and x is equal to 3. But they are unacceptable to us. Why are they unacceptable to us? Because we have already put a condition that x should be less than 0. That means we will have to reject both the values of x. X is equal to 2 and x is equal to 3. That means we have got no answer. No answer from case 1. Now moving on to case 2 where x is 0. Now when x is 0, we have got the quadratic to be x square minus 5x and the equation to be x square minus 5x is equal to 0. Alright. Now again I can just factor out x from the left hand side. So when I factor out x, I will get x multiplied by x minus 5 is equal to 0. So from here I have got one value of x to be 0 and the other value of x to be 5. Now x is equal to 0 is acceptable to us, but we will have to reject x is equal to 5 because the condition of case 2 is x is equal to 0. All right, so that's an important thing to note here, that the condition here is x is equal to 0. Now, if x is equal to 0, x cannot be equal to 5. So we will have to reject x is equal to 5. And we will accept x is equal to 0 from case 2. Now, moving on to case 3 when x is greater than 0. So when x is greater than 0, the quadratic that we will consider is x square minus 5x plus 6 minus 6. All right, and the quadratic equation that we will get is x square minus 5x minus 6 is equal to 0. All right, now here what we will do is we will factorize this quadratic equation by splitting the middle term. So here we have middle term as minus 5x. I can split this as x square minus 6x plus x minus 6 is equal to 0. Now, if I further factorize this, what I will get is x minus 6 multiplied by x plus 1 is equal to 0. Now, the product of these two terms is equal to 0. That means either of them can be 0. So, either x minus 6 can be 0 or x plus 1 can be 0. So, when x minus 6 is equal to 0, x is equal to 6. And when x plus 1 is equal to 0, then x is equal to negative 1. But again, we do have to check the condition of x. All right, so we know that x is greater than 0. If x is greater than 0, this is an acceptable value for us. But as x is greater than 0, x is equal to minus 1 is the value that we have to reject. All right, so we have got case 1 here where x is less than 0 and x square minus 5x plus 6 is equal to 0. From here, we did not get any value of x because the values of x that we got was 2 and 3. But we had the condition that x is less than 0. So we would have to reject both of these values. All right. Now from the second case where x is equal to 0 and x square minus 5x is equal to 0, we got two values of x, 0 and 5. Now we accepted x equal to 0, but we had to reject x is equal to 5 because in the case or in second case, the condition was x is equal to 0. So we have got x is equal to 0 as one solution of the quadratic equation. Now from case 3 where x was greater than 0 and x square minus 5x minus 6 is equal to 0, we got two values of x as 6 and negative 1. We had to reject negative 1 and accept 6 because it was given in the case that x should be greater than 0. That means we have got one value of x which is equal to 6. But that's not the question here. We need not to find out the value of x, okay? We wanted to find out the number of non-zero solutions. Now we know that 0 is not zero is not acceptable in non-zero solution, but 6 is acceptable for us, and therefore we can say that we have only one non-zero solution, and that is x is equal to 6. So basically the answer to this question is 1, because in the question it's been asked the number of non-zero solution, and that is x is equal to 6. All right, so that is the one non-zero solution of this quadratic equation. I hope you understood the question.